Alright, so in this video, I'm going to show you all how to do precipitation reactions, okay? And I'm going to go over some examples for you, and then you're going to finish the rest on your own. So we are going to try to predict whether a precipitation reaction will take place between two aqueous solutions of ionic compounds. A precipitation reaction occurs when a solid is formed. So for example, let's say we take a solution of lithium carbonate, which is aqueous, and combine it with a solution of magnesium nitrate, which is also aqueous. What will we get? Okay, so if you remember, double replacement reactions follow the general equation AB plus CD yields AD plus CB. So in these types of reactions, we are going to be dealing with two compounds, and they are going to switch places, forming our double replacement reaction. And then we have to figure out, will the products be aqueous or will they be solid? So let's look at the procedure. Okay, step one, write the formulas for the products. Remember to check the charges and crisscross if necessary. So we have our lithium carbonate added to our magnesium nitrate. So I'll show you a little trick to show you how to do this later on when we do the examples. But remember, we take the two outside either elements or polyatomic ions, and then we take the two that are on the inside, making sure that the metal always goes first, followed by the non-metal. So when we do that, lithium has a positive 1 charge. It's going to go with nitrate, which has a negative 1 charge. And don't worry, the table that I'm going to show you has all the charges that you're going to need. But when I combine lithium and nitrate, we get LiNO3. Li is positive 1, NO3 is negative 1. Then we take the two that are on the inside, putting the metal first. Mg is our metal, which is a positive 2. CO3 is a negative 2. So positive 2 and negative 2, they cancel out, add up to 0. So we get MgCO3. So these are the products. This is our double replacement reaction. But we started with two aqueous solutions. Let's see which one of these forms a solid. So in step 2, you're going to use the solubility table to determine whether either of the possible products is insoluble or solid. If either possible product is insoluble, a precipitation reaction takes place, and we're going to continue on to step 3. So here is our solubility table. On the left-hand side, we have a list of different types of cations. So remember, our cations are our positive ions. We have some alkali metals in group 1 have a positive 1 charge. We have most alkaline earth metals, which have a positive 2 charge because they were in group 2. We have some transition metals, like copper and zinc and iron here. And then we have some other transition metals like silver and lead. The top part of our table has our anions. So remember, these are negative. Okay, we have nitrate, which is a negative 1. Chloride is a negative 1. Hydroxide, negative 1. We have sulfate, which is 2 negative. Carbonate is 2 negative. Here's a new one. Oxalate is 2 negative. And phosphate is 3 negative. So what you do is you take the two ions, one that is a cation and one that is an anion, and you match it up in the row and the column, and you want to see, is it aqueous or is it solid? If it's aqueous, we would write AQ. If it's a solid, we would write S. So our first one was lithium nitrate, LiNO3. So I would look at lithium here, and then here's my nitrate. So lithium and nitrate, that is aqueous. We say that is soluble. That means it'll dissolve. The next one we have is MgCO3. So here's my magnesium right here. Okay, so we're going to look at our second row, and then we're going to go over until we get to our carbonate, CO3, and we see it is a solid. So we say that is insoluble. Okay, that is going to be our solid. So what we're going to do is we're going to put our S for solid next to the insoluble product. This is what is known as the precipitate. Okay, the solid formed is called a precipitate. It does not dissolve. And then we'll put AQ next to the compound that is soluble, and it will dissolve. So lithium nitrate was aqueous, and magnesium carbonate was solid, and we decided that because of our solubility table. Okay, before we actually get to the precipitation reactions, let's do some examples determining if you can read the table and determine if the following substances will be soluble or insoluble. So the first one that we have here is calcium chloride. Okay, try and figure it out on your own first. But you'll see here we have calcium and then chloride. And when we line them up, we see that it is aqueous. So I'm going to just write that down, and I'll bold it and put it in red for you so you can see. Okay, try the next one on your own too. We have silver hydroxide, AgOH. All right, Ag is our metal, so we're going to find it in our cation down at the bottom. And we're going to go over to our OH, which is the third column, and we'll see that it is a solid. All right, what about sodium nitrate? Again, try to do this on your own before I put up the answer. Okay, sodium is right here. We have Na positive. Nitrate is our first one, and we see that it is aqueous. Okay, we have one more. We have zinc phosphate. Okay, here we have zinc. It is 2 positive, and then phosphate is all the way at the end up here. So we go zinc, and we go to phosphate, and we see that it is a solid. Okay, so by using the solubility table, we will determine whether a substance will form an aqueous solution or whether it will be solid. Okay, I want to do the first two to show you how to do the double replacement reaction in case you don't remember, and then we'll use the solubility table to determine if our products are aqueous or solid. Okay? Number one, we're going to take some silver nitrate and we're going to add it to some potassium chloride. So in all of these examples, we're starting off with 2 aqueous solutions. These have all dissolved, but when we mix 2 aqueous solutions, sometimes we form a solid. So let's go ahead and figure out. So the first thing we need to do is determine our products based on our double replacement reaction. So remember, the 2 species on the outside come together and the 2 species on the inside come together. Now, one little trick to help you out is look at the table above to determine what the ions are, and let's write them. So for example, for Ag and NO3, I see that Ag is positively charged, so a positive 1, and NO3 is negatively charged, so a -1. So what I'm going to do to help me out is I'm just going to write a +1 and a -1 for my charges. And I want to do the same thing for K and Cl. Okay, I'm going to go up and find K, it is +1, and my anion chloride, it is -1. So again, I'm going to write a +1 and a -1, just so I know what the charges are. Now this makes it very easy to determine my products because everything will add up to 0. There's no crisscross rule that needs to being charged. So my Ag is on the outside, it's going to go with Cl. So since we have +1 and -1, we're going to get AgCl, okay? Silver chloride. And then I'm going to add, because I'm going to make two products, now my inside, okay? NO3 is nitrate. It's a polyatomic ion. You must never break it up. It is -1. Potassium is our +1. Our metal always goes first, so I'm going to write KNO3, okay? Remember, this button here is your subscript, okay? The one with the little 2 below your font size. So I can do that to write my subscript. Okay, so the two products that I formed were AgCl and NO3. Now I need to determine which one of these is a solid, if any of them are, okay? Or is it aqueous? Because the first one I want to look at is AgCl. Okay, so I'm going to go up to my solubility table, and I see Ag, and I go to Cl, which is in my second column here, AgCl. That gives me a solid. So what I'm going to do is put parentheses S for my solid. That is going to form my precipitate. Now my KNO3, again, I'm going to go up to my solubility table, and I'm going to find my K and my NO3. They're both in the first row and first column. That is aqueous. So when I'm here, make sure I've clicked off my subscript. I'm going to put AQ in parentheses. So I've figured out that I can add these two solutions together to make a solid silver chloride. So that's all you have to do. You write out the examples, write out the products, you determine the ion charges. That will be helpful, not necessary, but definitely helpful. And then you use the solubility table to determine if it's solid or aqueous. Let's do the second example together. So let's have two solutions of calcium chloride and sodium phosphate. Again, to help us out, we're going to write the charges. Okay, so I know calcium is in group 2, so that's a +2. And chlorine is just like above, it is a -1. I'm going to do the same thing for sodium. I know it's a +1. Phosphate, let's double check. If we look at the table at the top, we see it is PO4 with a -3 charge. Okay, so I'm going to write -3 as my charge. So now that I know what my ions are, I can now do my double replacement reaction. And because some of these might not add up to 0, I have to use my crisscross rule. So let's take the outside elements first. I have calcium, which is on the outside. And then I have my phosphate here. So calcium is +2. And phosphate is -3. That does not add up to 0. So hopefully you remember you have to do the crisscross rule. So I'm going to write my Ca first, and I take the opposite charge. That's my 3, and I'm going to make it a subscript. Then I write my PO4. Okay, because I can't change that in any way. And then I write whatever charge was left, and that's a +2. But if you remember, if I write a 2, that looks like 42. So what I need to do is I need to put parentheses around that PO4 and then give it the 2. Okay, remember, if you ever have multiple subscripts, okay, you must protect, right, the parentheses around your polyatomic ion. So calcium phosphate is the first one. Now let's consider the second one. We're going to do the inside species, the inside elements. I have chlorine and sodium. Now, you do not bring these two subscripts over that I'm highlighting. Okay, do not just write those down. You just take the element itself. So Na is a positive 1, Cl is a negative 1. Positive 1 and negative 1 adds up to 0, so we get NaCl, sodium chloride. So, now that we know our two products, let's determine if we have a solid or an aqueous solution. Let's start with calcium phosphate, Ca3PO42. I'm going to come up. Calcium is right here, so second row. Phosphate, we remember, was at the end. And we see that it lines up to make a solid. Okay, so here we're going to make our solid. And then we have NaCl. Na was in our first row, Cl was our second column, and we line them up and we see that it is aqueous. So I'm going to go ahead and put this as an aqueous solution. So you have everything that you need in order to be successful. Make sure you look at the examples that I've done here. You can copy them onto your own Word documents. You have 2 done. There are 10 total, so you have to do 8 more of these. Okay? I recommend that you write the charges so you know how to do your crisscross if necessary. Remember that if it's a polyatomic ion, do not change it. If it's NO3, keep it as NO3. If it's PO4, keep it as PO4. If you ever have multiple, you must put it in parentheses.